Now.
Now?
Yep. We
Awesome.
are live.
Hi, everybody. Hi, everybody. My name is Dan. I'm the head of developer relations here at Scaleway. You are tuned in to the very first edition of the Scaleway sessions live on Twitch, rebroadcast on YouTube. Join us on our community Slack. We'll get the details for you there later, or on Twitch, or on YouTube, or tweet at us if you feel like it. Today, I am joined by a couple of illustrious members of our family here at Scaleway. We've got Eli, we've got Diego, and we've got Alexandre. I'll start with Eli if you'd like to say hello to our home audience.
Hello, my name's Eli. I'm a developer advocate here at Scaleway. My pronouns are they and them. And I am really excited to learn about Kubernetes today because I'm a bit of a newcomer to it.
Thank you. Glad that you could make it. Glad you could be here. And if you like our style, if you like Eli's style, we're going to be seeing a lot more of them going forward here on twitch.tv/Scaleway. Diego, your turn.
Hey, so yeah, I'm Diego, a web developer jumping into the cloud, developer advocate as well, and I'm supposed to handle this stream today. So if it looks weird, which I know it is right now, it's my fault. Sorry, I'll be working on that.
All right, thanks, Diego. Diego is going to be doing most of the heavy lifting for us behind the scenes today, not only participating on the stream, but also acting as the producer, managing the software, the scenes, so on and so forth. So, thank you so much, Diego, for helping out with that. Last and, of course, certainly not least, we've got our special guest for today, Alexandre. Would you like to say hello?
Hello, everyone. Alexander. I'm a PMM, product marketing on Kubernetes. So I'm between product and marketing. That's basically my job. And happy to be here to talk about Kubernetes together. Yeah, thank you, guys.
Well, thank you for coming on. Thank you for coming on. So if you're new to the Scaleway sessions, and of course you are because this is the first time we've ever done it, the format is fairly straightforward, right? We get on stream, we have a special guest or not, and we just kind of see where it goes. Today we're going to be talking about Kubernetes. That's the theme that we wanted to tackle today. That's why Alexandre is with us, right? He's one of our resident experts on Kubernetes. For the remainder of the streams, we're doing this weekly throughout the month. We're going to be sticking with Kubernetes as a theme because it's good to have a theme, but it's not the only thing we're going to talk about. You know, we can talk about tech, we can talk about DevOps, we can talk about web development, we can talk about knitting, right? We're going to see where this goes. We're going to have some fun. And as always, if you have any questions, if you want to participate, and we do encourage you to participate in the discussion, if you have questions you want to ask, if you have things you want to say, we're on the Twitch, we're on YouTube, we're in our community Slack. You can even tweet at us. I got an eye on that as well. So definitely join in on that conversation. Excellent. So I'm going to kick us off with a softball, right? If you're so inclined with the baseball analogies, with an easy question, right? And I will ask. I'll ask our guest first. I'll put him in the hot seat. This is Alexandre. Alexandre, what got you into Kubernetes? You could have picked a ton of different technologies. You picked this one. Why?
That's a pretty tough question. And I think there is a ton of answer. But I think, you choose Kubernetes because you want to solve a specific problem, or you have a specific use case, and then you just put all the options around the table. And today, nowadays, Kubernetes is one of the good way to solve that. For example, I would say the first use case I have in mind is scaling up and down, because Kubernetes is definitely the tool you will use for that, to have a big infrastructure at a time when you have a lot of people to serve, and scaling down to when it's quiet and you don't need that much of infrastructure. Another part of the success of Kubernetes, I would say, is linked with microservices. We all know that it's something very common right now, but you need something to orchestrate all your container where you put your microservices, and I think it's a very useful tool to do that. Yeah. So
Right on. So basically, just it's a useful tool. It meets the needs modern computing, right, with the idea of scaling and microservices fits that niche fairly well, and then that's something you're interested in. That's something that's compelling to you.
Yeah, definitely.
Right on. Excellent. That's a good summary. So, Diego, I've had the pleasure and the honor of knowing Diego for a little while now. And I remember one of the earliest conversations that I had with Diego, I was like, Diego, tell me about Kubernetes. And it was an uncomfortable silence. So Diego's come a long way. Diego, talking about Kubernetes, we're talking about sort of your journey into the world of cloud as a front end developer. For you, what is interesting? What's compelling about Kubernetes as an area of study?
Still an unknown, not a complete silence at this moment, but I'm struggling to see the need from my own perspective as a developer that just codes some apps for fun during the weekend. Like, why should I care about Kubernetes for my home finances tracking app that I just coded, or for my home automation or IoT management stuff if I'm only using it myself? So that's just the question that comes up to my mind on and on. And I think that maybe that's not the best approach for my specific use case. What do you think?
Yeah, and that's fair. We fall into this trap, I think, as technologists, of finding solutions to problems that don't exist. Right? Kubernetes is a solution. The question is it the solution for the problem you're trying to solve? Right? And I think that's a completely valid approach, and these are questions that are good to ask. Right? If all you have is the hammer, everything's a nail. Right? So if the only thing you have is Kubernetes, then it's like, well, of course my blog needs to be deployed on a multi-cloud strategy, and I need to have 15 different clusters, and so on and so
For
forth,
my
right?
10 visitors, yeah.
Yeah, exactly. Yeah, exactly. So I mean, that's fair, right? You don't want to think about, is Kubernetes right for me? Like, ask your doctor. That's a fair. Yeah, that's a fair question. Eli, Kubernetes, why?
So I didn't know much about it before I actually interviewed at Scaleway, and for my interview prep, I learned about user authentication in Kubernetes and put together a little talk, because as a developer advocate, one of our main skills is just being able to say words good. So one of the things that really interests me about it is it has this reputation for being complicated and quite intimidating to get into. And yet it is so popular, it's so widely used, and people are like mad about it. So I'm really interested to learn what makes that complication and that sort of intimidating nature worth it. There must be some really interesting, cool, weird stuff in there, and I want to know about it.
Yeah, that's fair, right? So there's the aspect of it which is, it is a tool, it's a platform, it's something that can, as Alexandre hinted at, solve a particular use case, can be used in a variety of ways for practical concerns. But there's also the almost the intellectual exercise of it, right? Like what is it conceptually? How is it designed? Why were certain architectural decisions made versus others? What are the trade-offs? Right?
Yeah, it's almost like sort of anthropology of computer science, right? Like has this thing emerged in the way that it has? And that really interests me. So.
Yes, so that is actually super interesting, and definitely an avenue we could go down, if only we had somebody who was a Kubernetes expert on the stream. Interesting. Okay, so Alexandre, maybe you can help us out a little bit here, right? When we're thinking about Kubernetes as it exists today, it's a behemoth, right? It is a massive, massive ecosystem, layers upon layers with plugins and add-ons and forks, and different types of software and different types of things you can pay for. People definitely want to sell you Kubernetes things, right? So it's almost difficult to conceptualize even where to get started. So instead of just going and doing the how-to, why don't we open our minds a little bit and think about more like, where did Kubernetes come from? what was Kubernetes trying to solve when it was new, right? Someone had to sit down in front of their IDE and start writing code, and that code eventually became Kubernetes. Like, what was that person? We're going to speculate a little bit here, right? What do you think that person was actually trying to accomplish? Best guess.
That's a question for me.
Yeah, well, it's a question for anyone. I'm aiming it at you, but we can go off, right?
Yeah. So yeah, Kubernetes, from my knowledge, I know it's a very wide topic, and there is many people who do like a legend because it's a project from Google, as we know. It solves they had to scale actually. They had to answer more and more requests, and actually also handle many projects side by side, and always putting in front one application. So how you have something speaking well together, but for the end services, you don't see the difference. You just type Google, you have ton of services, but you are in the same environment. And I think Google had very specific um, objectives or goals that other company doesn't have or don't have, or they had first before everyone else. And that's why I think they create this tool of Kubernetes and manage many containers, and I think they understood before everyone the need to use container at scale, and how it could be very benefic for the company and for the service for their client. So what was the question again? But
well, I mean, the question
think,
was why did somebody sit down and start writing this code to do this thing that ultimately became Kubernetes? Yeah, and I think you hit the nail on the head there, right? Which is, someone went, I have containers. I have a lot of containers, right? And not only do I have a lot of containers, I have a lot of containers on a lot of running in a lot of different environments. Is there a way that I could make that suck less to manage? Yeah. Then one thing led to another, and you've got Kubernetes, right? I don't know if that's the origin story, but it seems plausible to me, right? Question then to my mind is if we're rolling forward with the assumption that was the problem that was trying to be solved, did the problem get solved? Is Kubernetes the thing that allows us to manage containers, for example, at scale? Did we actually solve the problem? What do you think?
And I think it solves the problem, but create a new one.
As everything does.
Yes, that's the things about technology. About you find one stuff to fill the hole, and then you have many other.
Right. Yeah.
And you get to the stage where you think, you know what, teaching sand to think was a mistake. Computers were a mistake. I want to go back and live in a cave.
Well, I don't know if living in a cave, I think, has some downsides with the dampness and the bears and whatnot, but
and you start trying to solve these problems, and eventually you get back to Kubernetes.
Yes, exactly. Yeah, but what I would like? I would like fire, and then this person over here has a bear skin, and I don't have a bear skin. Can I trade them something? And then one thing leads to another, and you're deploying infrastructure in the cloud again. Mm-hmm. So as we, everything with technology is cyclical, right? Yes, precisely. So I'm going to go ahead and I'm going to make a wild assumption here, and I realize this is a wild assumption. I'm going to make it is that if you're joining us on the stream today, you've probably at least heard of Kubernetes, right? Which is why we're not kind of diving into the basics of the what is it and so on and so forth. If you have never heard of Kubernetes, joining us for the first time, welcome. So good to have you. If you have any questions, of course, hit us up on the Twitch stream, hit us up on YouTube, hit us up on the Scaleway community Slack, if you happen to be on it, right? I've never heard of it. Fair enough.
What's a good summary of what Kubernetes is?
What is a good summary of Kubernetes? Boy.
I
You
mean,
know
I
what?
can give my barely better than a layperson understanding, which is
Do it.
it's an orchestrator. You have a lot of containers. They need to talk well to each other. It gives you high availability and auto scaling. And nobody knows how to pronounce the CLI control tool for it. You've got
In
kube
fact,
control, kubectl, kubecuddle, I've heard as well. I've heard
yeah,
somebody say cubby cuddle once, which I
Cubby,
didn't like very much.
Kubacuddle.
Yeah. No, cubby cuddle.
Yeah, that one's good too. I'm going to be doing a lightning talk on this exact subject on Tuesday next week at Kubernetes Community Day in Paris. I'm going to be on stage during plenary doing a lightning talk, and I'm going to run through every single way I can think of to pronounce that tool. We're going to see how the crowd likes it. Big shout out to Waldo Grunenwald, colleague of mine from years gone by, who first attempted this on stage back in 2018. And I'm going to see if I can pull it off in French in front of a Parisian audience. So that should be a lot of fun. Yeah.
So
Very
what's the
good.
goal there? Are you gonna pick what's the best one based on applause, or?
That's not a bad idea, actually, right? We'll just go through the list and be like, what's our favorite one? And then that's
Yeah.
going to be the canonical pronunciation going
Either
forward.
that or you'll get a lifetime supply of tomatoes thrown at you as you come off stage.
Oh man, people get angry about this stuff too.
Yeah.
Right? Yeah, like how do you pronounce, SYSCTL, like that Linux tool, right? Like how do you pronounce that? Also, like /etc, that directory on a Linux machine, how to use it? Anyways, big old religious wars, right? Very Vim versus Emacs stuff. It's fine.
Oh yeah.
We're gonna get on stage. We're gonna have some fun.
VIM?
Yeah. So Kubernetes, right, is often, because in the world of computers, we don't like to use more characters than necessary. You often see it rendered as K8s, right? Is an open source system for automating deployment, scaling, and management of containerized applications. That is literally the definition if you go to kubernetes.io.
I wasn't far off then. Hey.
Right?
You learn it by heart.
So, it's simple. It's one sentence. I like the brevity of that, right? Gets right to the point. The other thing that I think is interesting here, and I'm going to, again, quote from the page, and then we're going to open it up on that, is it groups containers that make up an application into logical units for easy management and discovery. So there's actually a lot of information encoded in just that sentence, right? Then it goes on to say, Kubernetes builds upon 15 years of experience running production workloads at Google, which is something you alluded to earlier, Alexandre, right? This was originally a Google problem, and they came up with a Google solution, right? And it says, combined with best of breed ideas and practices from the community, the marketer in you, Alexandre, is loving that, I'm sure. But the point here, right, is that we have a couple of keywords here: automating deployment, scaling, managing containerized applications, container groups, logical units, and discovery. Those are the key words there, right? That I think, if we want to understand what Kubernetes is we have to dive into those words. So I'm actually going to start at the very last word, which is discovery. I'd like to think that we probably are aware of open source. I'm not going to go into a big discussion about what open source is or isn't, mostly because I don't want to start a flame war on our very first stream, right? Automating deployment, scaling, management, that's all good stuff. I want to get to that very last point, because I feel like it's the one that might be the least well understood, especially for people who are getting into Kubernetes for the first time. And that is discovery. What is that word? What does it mean? And why is it compelling? Why is it a big part of what makes Kubernetes the platform? Alexandre.
Yeah, you have many ways to discover, actually. Depend of if you're just starting or if you are maybe an expert, if you consider yourself as an expert. But yeah, discover the impact you can have with your application with Kubernetes. discover the new ability of your application, like what is the traffic or what is the scaling you can go up to. Maybe it's the one kind of discovery. I think as it's a moving environment, you can rolling back your deployment if you go wrong, or if you can go up and have new version. So I mean, it's a moving thing, so you always have new stuff to discover and new stuff to us, new actual things to maintain. I would say that's kind of discovery. Maybe you have other things in mind. I guess you can put many concepts behind discovery.
Yeah, for sure. It's an overloaded term, right?
Mm-hmm.
And actually, I literally just got a message. Wanted me to transmit it anonymously. That's fine. It's cool. You can do that. I'm okay with that, by the way. Which noting that discovery could also refer to service discovery, right? So, for example, if you are deploying applications and those applications provide certain functionality, that there are mechanisms in which to have systems auto-discover what those things are, right? So to anonymous statement maker, yes, but is that actually part of Kubernetes, or is that a higher order function? Are we starting now to get into the world of like service meshes? Are we starting to get into the world of, deployment and tags, and like how are we actually announcing the capabilities of the pods and the clusters that we are deploying? Is that native Kubernetes, like that? You pull the repo and you run it and you get higher order service discovery, or do you need something more to make higher order service discovery go? Open question. Any ideas?
No, not really. To be honest, I guess in both worlds you have, but in terms of technology, of course, you have this ability to automate many things and let your control plane, I would say, discover the new. I don't know if it's very English, but
We'll
let it
translate.
run. Let it run.
You could say it in French. I'll translate. It's not a big problem. Don't worry about it.
So you mentioned there the control plane. Can you explain to us what that is? Because I heard that term going around quite a lot.
Yeah. So the control plane. A control plane is basically the. I like to describe it as the brain or the master of master node of your Kubernetes. Like it's the things in Kubernetes that automate all the how to say the task, the job Kubernetes have to do, like auto scaling, scheduling, auto healing. Like if a pod or a cluster is failing, it will renew or respawn a new one. So that's where you put all the information, your manifest. That's another stuff from Kubernetes, but it keeps control of your Kubernetes. So it's a very important things of your Kubernetes infrastructure.
So
it's a good.
It's that sort of cloud-specific control logic.
Yeah.
Right. And I shouldn't say cloud-specific. It's the control logic of how everything runs, right? So, you've got your clusters. Your cluster, is it's worker machines that are grouped together, right, into a set. Those are called nodes. They run containerized applications, and those clusters have a worker node, and the worker nodes, they host they got the pods, the components of the application workload, and so on and so forth, right? So you've got these moving parts, I guess is what I'm saying, right? That are sort of logical groupings, and the control plane manages the worker nodes, right, and the pods in that cluster. Okay, so as Alexandre, sort of alluded to, this is going to be things like, dealing with making sure that the correct number of pods are running, right? If we got a high availability scenario, making sure the correct number of clusters are routed up. Fault tolerance is going to be part of that. So kind of making decisions about, scheduling, dealing with how many replicas need to be spun up or spun down, whether the requirement is satisfied. And then, then you could start to add logic into that, right? So for example, Alex again alluded to earlier, this idea of auto scaling. So based on triggers from your monitoring, whatever you've got going on for monitoring, right? You could go, well, if our CPU gets to this point, then we need to, add more fuel to the fire, so to speak, right? Or if we drop below a certain number of requests, let's spin down some pods, or let's eliminate a cluster entirely, whatever that means, sort of a thing. So the control plane is going to be kind of where that logic happens.
I remember reading an article that said there's a lot of reasoning that goes into how many, because you don't just have one version of this running, right? You have it across a number of nodes, so that if one dies, you've got others to pick up the slack. And you want always to have an odd number, I think, so that if I forget the exact, there's sort of mathematical reasoning behind it, so that if for how many node deaths you can tolerate before your system no longer has the ability to form consensus as to what's actually happened. If you've got two different nodes writing different data to the database, and you don't have enough control plane nodes to know what really should have happened and define what the truth is, that can be bad.
No. Epistemological arguments. Oh, it's Friday. We can't go into that. No. What is the nature of truth? Cool. So we got a question on the Twitch. Excellent.
Just a question from my friend Mike.
From Ukmds.
UK Mads. Yeah.
Well, why don't you read out the question there, Eli?
Question from Mike. I've seen quite a few orgs rely on the fact that the networking layer can be tightly controlled to isolate systems. Is that not a good thing? I'm not sure I understand the question.
So, the networking layer can be tightly controlled to isolate systems. The question is that not a good thing?
Depends.
It's a bit of a leading question.
Evergreen answer. It depends.
Right?
What are you trying to do?
So this is in reference to discovery. Okay. All right. There we go. Isolate it a little bit. Well, do you have an opinion on that, Alexandre, before I go off half-cocked?
I would say, just like Eli, it really depends on what you want to achieve, on the security you want to have or not, or you need or not. Sometimes you don't need that level of control, and you just let it go.
So the answer, like so many things in the world of technology, is it depends.
Yeah.
I know that at my last place, a developer tooling company, we had enterprise installations that were running Kubernetes within their closed network to serve the tooling internally in their network. And so, that's obviously you've got a different networking situation there and a different sort of threat model that you're going to be dealing with and constraints that if you're doing something that's deployed to the public web.
Yeah, and so if you're dealing with constrained or environments that have certain types of constraints, those could be security constraints that you've alluded to. Those could be regulatory constraints, where you actually, as a result of some type of particular certification, have to be able to make concrete statements about which systems can and can't communicate with one another, and about the ways in which those systems can and can't communicate with one another. That's going to be important, and Kubernetes has a lot of different ways these things can be configured, a lot of different ways to control channels. Just thinking about even just containers. Let's put Kubernetes aside for a second and just think about containers. And to simplify the conversation, let's just think about Docker. I know it's not the only container. I get that. But if we Docker the big one, everybody's generally fairly familiar with it. Think of just all the different ways to configure networking in the world of Docker, right? That on its own is a big learning curve. And so now if we're talking about how are we orchestrating large numbers of containers on a variety of systems, across potentially multiple networks, logical or physical, right? That could be in different organizations that may or may not have anything to do with each other. To come back to the question, that relying on the networking layer can be tightly controlled by systems is not a good thing. Again, it's a weaselly response, but it depends.
It's a classic senior developer response, I would say.
Yes, exactly.
Yeah.
Exactly.
I mean, thinking about security in Kubernetes, as again somebody who's quite new to it, it seems to me that there's like just an enormous surface going on in almost any deployment because of that flexibility of you've got so many options to configure it, and so that it like is. I don't know to what extent there are sort of golden paths defined for, okay, you want to do this thing and here's the best practice way to do it that is relatively hardened against certain attacks, or sort of being quite vague here because I don't know enough of the specifics. But it seems to me like securing a deployment must be a Herculean task.
One of the criticisms that was levied against Kubernetes, I don't want to say in the early days because the early days was very early, but let's say within the past 4 or 5 years, right? Was the same type of criticism that gets levied against a lot of late, early stage software, which is that it's expected to just work out of the box. That's the ships with sane defaults, right? You run an executable and something happens, and the thing that happens appears to be useful, right? And this is oftentimes sort of a product decision, whether it's being made consciously or not, right? You want people to feel like they're ramping up into things. You want to encourage people to try the thing out. You want to give people a sense of accomplishment sort of out of the box so that they keep using the thing, keep wanting to use the thing, instead of just shutting that down immediately, going, oh God, like I have to like read an entire manual just to execute this binary. Like that's a non-starter, right? And I get that. So some years ago, one of the big criticisms of Kubernetes out of the box is you could make it go easily, but the thing that went was not particularly secure.
Well, I guess
right?
there's a trade-off there between, saying you want this thing to work out the box. That, by definition, means the tool has to be opinionated to a certain degree. If there's multiple ways to run the thing and you pick one to be the thing that it ships with, you've privileged that particular configuration, and that's maybe you don't want to make that choice as the maintainer, as the developer of a tool.
For sure. This I think also ties into the proliferation of the ecosystem tools, vendor tools, developer tools, managed solutions, so on and so forth around Kubernetes, where someone's going to come up with this particular set of opinions that you've alluded to, Eli, right? But these are the opinions that I or we have. And based on those opinions and the outcome of those opinions on how Kubernetes can be used, you will get this thing, and these are the trade-offs, right? So we're not going to talk too much about Scaleway on this, but here's actually, I think, an interesting segue to talk about that a little bit. So at Scaleway, we do have notably 2 different Kubernetes sort of products, right? And they exist separate from one another because they have different opinions, right? They have different constraints. They have different potential use cases, right? Alex, can you walk us through a little bit of what those 2 things are? But really what I want to drive at is what were the opinions there? Like, why are these 2 things separate from each other, even though they're both Kubernetes?
Yeah. They are both Kubernetes, true. So we have two different manage orchestrator, as we call. The first one is Capsule. It's basically Kubernetes managed by Scaleway that you can use in our own ecosystem, with our own instances. You have everything that you need to deploy your containers or use our control plane in our environment. The second one is Cosmos. as maybe the name sounds a little bit like a spaceship, but it's an hybrid cloud orchestrator. It means like we open the gate and you can deploy your containers outside Scaleway. So we have some use case on other cloud provider on premise, or you can even deploy on a Raspberry Pi, for example. There is some funny stuff to do with this orchestrator named Cosmos. Basically, you deploy wherever you want. You need to have yes, Diego. You need to have an IP, and that's it. Maybe someone once will try to deploy on a Tesla. Why not? But yeah, that's for another use case. For example, basically, it's for more redundancy, or if you want to deploy somewhere, Scaleway is not very close to your user, or you want to still use your on-prem environment because you invest in your servers. You don't want to throw everything by the window. So yeah, it's an interesting tool, and we have a very interesting use case with Cosmos.
Yes,
So
that could
the,
also be used to keep particular data on site as well, if that's
Yeah,
necessary. Like there's going to be a lot of use cases where you've got client information that can't leave your premises. Yeah.
so the first one that you were talking about is more what I think might be considered a classic sort
yeah,
of managed Kubernetes product that one could imagine from a variety of vendors in a variety of contexts. The sort of thing one might build oneself as
yeah.
well, right? If you have a
I would
bunch of
say that.
computers and you're like, I'm going to make Kubernetes go on them, right? So it's the bits and the pieces, and it's more or less self-contained, right? Like it's kind of meant to run Kubernetes in one place over here, and it goes, right? Whereas Cosmos, you mentioned a key word here, and I want to get to that key word. There is we're talking about orchestration, right? It's more about how these different bits and pieces work together than where those bits and pieces are. Am I understanding that correctly?
Yeah, yes. Uh, sorry,
Good.
my sound quality is not that good, but yes, exactly. The keyword is orchestration. They do the same job actually. They have the same process, but then are not on the same place or not deploy. But you could use actually Cosmos exactly as a capsule if you only use Scaleway environment, then it will exactly do the same stuff as a capsule. But why you would use Cosmos if you can use a capsule? That would be strange. But yeah, exactly. That the difference is where.
Yeah, it's
Fair enough.
agnostic as to where it's all the worker nodes and so on. It is that the control plane still will live within Scaleway infrastructure.
Yeah, it has to because it's a managed product, so
Sure.
we,
Yeah.
we keep it home.
Yes. Yeah. But where the worker nodes are, Cosmos is basically just agnostic to that, which is I think that's super cool. It's also making the bit of my brain that's worried about security also want to ask questions, but I don't know enough to ask the questions that I want to ask. So one
So
day.
if we want to drill down a little bit on here, and I'm going to put you again on the hot seat, Alex. So if we could conceptualize a Kubernetes deployment, you of course have the kube controller manager, right? So that's the control plane, that component that runs the controller processes. You've also got the cloud controller manager, right? Which is the control plane component that embeds that cloud specific control logic,
Yeah.
right? And those two things are separated from one another for reasons, right? We could talk about the history of Kubernetes and why these two things are separate from each other, but they are separate, right? When we're talking about these different opinions and these different ideas about the product and how it's designed and how it's meant to be used, is it that the cloud controller manager and the kube controller manager are then running, for example, at Scaleway, but pretty much everything else could run externally? Like, could I literally be running my etcd, for example, elsewhere? Could I be running my API server elsewhere? Right? Or all these things still have to be inside of Scaleway, and literally the stuff that's not in Scaleway is like, my nodes, my clusters, my actual container sets.
Yeah. To answer your question, that's the final proposition. We keep the control plane, the kube controller, the cloud controller, the etcd, all this configuration stuff stay at Scaleway. And what you can deploy somewhere else are the worker node on the node, basically, on different environment. Yeah. But all the other stuff that would say link to the configuration are managed by Scaleway, and I think it's for the best.
Well, see, but that's the opinion.
Yes,
right? We're
exactly.
talking about opinionated software, and what kind of trade-offs are you going to make? And yeah, that's exactly it.
Because you mentioned people could install their own Kubernetes and do that by themselves. That's an opinion as well. There is actually a client at Scaleway. They do that. They have a server and an instance, and they use Kubernetes by themselves because they feel confident enough to run their Kubernetes. And I think it's great because it means they are good enough in their knowledge, in their confidence to do that. So that's a good thing. We say Kubernetes is complicated, and there are many opinions on that. So for diverse reasons as well. But if you use a managed product, and that's here I'm speaking for as a PMM, of course, you want to have this facility and this easy. You want to be the things easy to use. So as a managed product, you don't want to touch that much on configuration. Of course, you need to configure stuff, but the less you have in care, the better you are if you use a managed product, of course.
Yeah, there's this sort of the joke that goes around. I have a sticker on my personal laptop that says, like, there's no such thing as the cloud, it's just someone else's computer, which is, it's funny, but it's also really reductive because there's all of this work that goes into somebody deploying something into Capsule, for example, that it's not just someone else's computer, it's someone else's team of Kubernetes engineers wearing the pages, someone else's data center, keeping their towers cool, yeah.
It could also be still your computer, right? I mean, there's absolutely no reason where you couldn't be running the containers on your computer, but have them be orchestrated elsewhere, right? So in that case, if you're using a managed Kubernetes service where the control plane and whatnot is literally off in the cloud somewhere, the actual resources that are being consumed, the actual compute that is occurring could absolutely be literally the laptop in front of you, and that would ultimately be indistinguishable from a user perspective, whether the user is you or someone else. In that case, the cloud is literally your computer, not someone else's computer.
That brings me back to a question I wanted to ask earlier. So if I were administrating a cluster, a deployment, how often would I ever be touching the worker nodes directly, or am I always connecting to the control plane to if I wanted to know some usage stats on a particular node, am I connecting to the control plane, or can I access the nodes directly? And maybe the answer is it depends how you've configured your thing, but now that I think of it, that probably is the answer. But like, is there best practice around that, and if so, why?
That's a technical question. I think I don't have the ability to answer, but I know like there is a plugin or sometimes you just deploy another container who will do the monitoring for you. So that's
more containers.
Yeah. So you want have a better visibility, and then you end up to have a new container doing new stuff for you.
Yeah, who's monitoring your monitoring container?
Who watches the watchers?
Exactly.
But yeah, there is many way to do it, and I guess you don't touch that much the control plane or the controller. But I think there is a way. Maybe Dan, you have some knowledge about that, so you could share.
Yeah. So couple of different ways to tackle that, and it is very much an it depends. It always is, right? You mentioned another container that's running some sort of monitoring thing, right? So extrapolating from that, there's a word that you'll see come up when we talk about Kubernetes, we talk about container orchestrations, the idea of a sidecar, right? So the sidecar is this this extra little container that gets shipped along with all of your clusters, right? And it's not the thing that your clusters are doing. It's not literally your application or your database or your whatever, right? It's
not load bearing.
Yeah, it's not a load. Well,
okay,
it can
but if
be.
It went down, it might, it won't immediately impact service of
yeah. So the idea is it's not load bearing.
Yeah.
Right. The idea is that in principle, nothing inside of your clusters is load bearing. Mm-hmm. That's the idea, right?
The way you're saying that makes me think that that's not actually true in practice all of the time.
Look, people can do terrible things with computers.
Oh boy. Oh yeah.
Right.
So, I've seen some of them.
If you want to make a load bearing sidecar, and you could do that. Right?
It reminds me of there's an image of a coconut in Team Fortress 2 that it's just a PNG, and if you remove it, and it's not really referenced anywhere, and if you remove it from your installation, the game crashes and won't run. And it's because it's the default texture for objects that are never rendered or something.
Nice.
Load bearing coconut PNG.
Load bearing coconut PNG.
Mm-hmm. I love computers. I love game dev in particular for that kind of weirdness. But
yeah,
so a sidecar is where you might deploy, for example, your monitoring container.
Well, I mean, you could deploy a lot of things in there, right? So you could, for example, put an agent of some type in there, right, for an upstream monitoring tool. Mm-hmm. So Kubernetes itself, this part of the Kubernetes ecosystem has evolved quite a bit, where there are internal ways where Kubernetes can do reporting on its own resource utilization, its own metrics, its own numbers, the things that it's actually managing and thinking about and handling the logic on. And then also some system level stuff for definitions of system, because again, we're getting away from, it's a computer. Thinking about CPU utilization, memory utilization, and so on and so forth. But again, for values of, in ways that are actually increasingly complex as Kubernetes has gained in maturity, and also as the world of cloud has also become more complex, right? But then you're going to have things which are not part of the standard elements that Kubernetes as a platform is going to be aware of. And that's like application specific stuff. For example, if you're running, a database and you've got a slow query counter, mm-hmm. right? Kubernetes doesn't know anything about slow query counters. There's got to be some other way to exfiltrate or introspect that particular piece of information.
So you're rolling your own monitoring or using a tool that's purpose-built for that sort of thing. Yeah,
exactly. And so there's, again, many
and that
ways
might go into your sidecar.
Exactly. So you might ship a little monitoring agent that's going to go out with that, right? Yeah, exactly. Is it the only way to do the thing? No, there's never only one way to do the thing. That's a way to do the thing, for sure. What you don't want to do is literally put the agent inside of the container of the thing you're trying to do. Because that is when you start making those terrible mistakes about load-bearing structures, right? Hence the whole idea of the sidecar, right? If the particular node inside of your set blows up for whatever reason,
you want to be able to retrieve the information about why that was.
Right.
And the way it blew up might have destroyed that. Yeah.
If the
you need your black box to be indestructible.
Exactly. If the container itself fails, how is it going to report on the fact that it failed? if the reporting mechanism is inside the container that failed, right?
Yep.
So there you go. Yeah. But again, a lot of ways to do that, right? And if we want to bring this conversation back full circle to Mike, UK Mad LZ,
Yep.
Mike? Yeah. The Mike, using the networking layer, tightly controlling the network layer to isolate systems, you can 100% have isolation at many different layers, right? Remember the OSI model, right? So there's many different layers there, right? And you can isolate at different spots on that, and then Kubernetes will do some of that, and you can actually subvert some of what Kubernetes is doing and have like rules on your switch, on your firewall, and then you can layer on top of that and like rub some WireGuard on it so that all those rules get ignored because WireGuard is magic, right? And how do you get data in and out of those containers? How do you get data in and out of those pods? How do you get data in and out of those clusters? How do you get data in and out of those sets, and so on and so forth, right? And it's all these different layers, and you're gonna have all these different basically tools that are out there, projects that are out there. It's open source, closed source, stuff you can buy, so on and so forth, that has those opinions about exactly that. How are these things logically related to each other? How are these things supposed to communicate with one another? And what can the vendor in question, and I use the word vendor here loosely, right? What can the vendor in question do to ease the pain of that whilst having trade-offs you're willing to accept?
Yeah, an abstraction that's minimally leaky, that's,
or maximally leaky, like that. Maybe you want that. Maybe you actually like this is a completely self-contained thing. It's 100% internal. It's on an isolated physical network that's not connected to the internet.
Mhm.
And we actually want it to be leaky because the leakier it is, the less literal CPU cycles we're dedicating to introspection and exfiltration of data, right? So, I mean, I'm making something up here. The number of times that actually occurs in the real world is probably not that big, right?
But someone wants it, and someone will maybe pay good money for you to go out and build it.
Yeah, exactly. So for those of you out there thinking, what's your next great startup idea? Super leaky Kubernetes?
Yeah.
I don't know. That's my free idea for you.
We should have one of these for every stream. We should have like a rolling list of startup ideas that we generate out of these.
Yeah, exactly. Next $1 billion valuation company. Wrong answers only.
So taking that into account and advocating for the folks out there who are not into Kubernetes still, like me, what do you folks suggest we start with? Should we just download Kubernetes and run it locally? Is K3S a good tool to do that? Or should I just, I don't know, use my Raspberry Pi instead? What should I do? Because I really want to learn Kubernetes this year and be good at it.
I mean,
Well,
I've always
what do you
thought
figure,
the best
Alex?
way. Yeah.
Oh, great. Go ahead.
I was just say the best way I've found to learn stuff is always like have a problem that you're trying to solve with it. So I guess find a problem that Kubernetes might help you with.
So,
I mean, you could run your HTML CSS blog on Kubernetes for your 10 viewers.
yeah.
But start with like a goal in mind, I guess, and then figure out how you solve it. But I will defer to the experts.
That's the thing, right? Because as we mentioned when we started, and it's almost been an hour, time's going like magically. Yeah, I'm running my local apps, so home services. So Kubernetes may not be the greatest solutions for me. I have my regular containers, one container, and maybe a watchdog that restarts the container if something happens. So I don't see any practical use for my specific weekend developer use case, but I still want to learn, right? And I feel like there's a lot of people like me with this kind of situation. I don't have the practical use case to work on. I still want to do it. I will still want to have 10 pods, 100 pods. But how should I do it? I need to learn, but I don't know where to start.
Yeah, still one pod is good. I know, like I will take my case. I deploy my first pod. It was a WordPress. Eh, but with Scaleway, because actually we like to test our product. We have a application library where we have a Helm chart. Helm chart is like how to say to describe that a small description of a deployment. Everything is automatized, and you just copy paste and you give it to your copy paste in your container registry, and then it's easy to deploy from capsule. And I just learned like that. I don't know if for you it's enough, but from my side it was just my first step, and I was happy to access to it thanks to the IP address, and say it works. Of course, it's not a lot of technology and a very hard use case, but it was my way to do it. I know there is many way to do it. On internet there is a lot of materials and stuff. I know Docker Compose is a good way to run it locally.
Right, and I'm familiar with that. I've used Docker Compose in the past.
Oh,
So
cool.
is that something that can help me better understand what actually is happening under the hood in Kubernetes?
I think the the best way is just keep learning and keep doing. I don't know. What
Well, I
would be
mean,
the
if you want to get started with it, certainly, if you happen to have access to uh, uh, a mechanism which is going to do the heavy lifting for you, like some sort of, again, managed Kubernetes service. We do happen to have one at Scaleway. You feel free to use whatever one is available to you, right? And if you just pop a Helm chart, and Alex mentioned this earlier, for those of you out there maybe not familiar with what a Helm chart is, maybe you've heard of something called configuration management, right? Like Terraform or whatever. Helm charts are like that, but for Kubernetes, right? So it's just a description of the thing you're trying to deploy and deploy. And there's a ton of like just default getting started ones. You can literally just go to the Kubernetes website, and there's like a getting started with Kubernetes, and you get a Helm chart, and you can deploy a thing, and it does a hello world, and like super, right? And that's enough to just get your toes wet with the terminology. Like, what do these words mean? I see this word in the documentation, but as engineers, the words don't mean anything until we've actually typed them out, until we've seen the results of these things running, right? And then the next question, of course, after that is, okay, great, I've done the hello world, and this, of course, is the killer for learning a new programming language, right? The number of hello worlds in programming languages I've done over the course of my career is astounding, and yet I'm competent in only a handful of languages. Why? Because I never had a reason to go any further than the hello world, right? So I really like that idea of start with something that you already know. Start with a thing you're already running. Start with a project that you've already, you're already maintaining, or actual software that is going. Maybe that software is something very simple. In the case of a blog, right? Like that, I imagine there might be a web server there. There might be some sort of way of serving files, right? It could be a database, I guess a static site, that's fine too, right? But like there's software there. If you were to imagine that software in the context of containers in your head, what might that look like? Well, as it turns out, that Kubernetes is just lots of containers, right? So you start with the thing you already have, with the, mentioned you use Docker Compose already, so start with the Docker files you've already got, right? Learn that terminology, and then see if you can glue those together. If you have a managed Kubernetes service, it's great. If you don't, K3S, we've already evoked that, right? So K3S.io, it's a certified Kubernetes distribution, so it's a real Kubernetes thing. It's not some wackadoodle project, but you can just like run it completely on your laptop. It's super lightweight. You have access to all the right tools. It's the real deal, but it's small. And it doesn't have to be. You can actually do fairly large scale deployments using K3s, believe it or not. There's also Rancher, right? So
Right, yeah.
Rancher's a CNCF project. Is it still Sandbox? I'm not 100% sure. So if you do know, hit us up after the stream. Tell me if it's still sandboxed or not. But then that's another way to go about it as well. So there you go. There's a couple of different options there. Yeah. Anyways, we are at hour, aren't we?
We are.
Oh my goodness, how time flies.
Exactly, it's like magic.
I can see you trying to play the drop.
Yeah, it's trying to you gotta get those lined up on your deck, man. So you can just hit them like a shock DJ.
I do have them here on my stream deck. I used to have them on my stream
deck. All
deck.
went off at once. That would have been incredible.
That would have been amazing.
Have to add that in post.
Fantastic. Love it. All right. On that note, I would like to thank our guest for the day, Alex, for being a good sport about coming on our first ever stream that we're doing together. Thank you so much, Alex. Big round of applause, virtual applause from.
Thank you.
From the tens in attendance around the world. Thank you so much, Eli. Thank you so much, Diego. Thank you so much to everybody that supported us in putting the stream together, that encouraged us to start broadcasting. We've had already some fun today. I'm really looking forward to doing more of these with the team. It's not always going to be the same composition. Sometimes 1, 2, 3. We're going to have different guests, have different topics. We actually got some special guests lined up. A little, can't say too much right now, but towards the end of the month, we're going to have some special guests. We're going to do some hacking on stuff live on air. I think it's going to be super, super fun. So if you like the style, if you're interested in participating, if you want to know more, if you want to get involved, obviously twitch.tv/Scaleway, get the YouTube. We're going to do a blog post. Hit us up on the Slack, the Scaleway community Slack if you want. Find us on Twitter. Find us on Mastodon. Get a hold of us. Get involved. We want to hear from you. So thank you very much, everybody. We'll see you next time.
Thank you, guys, for waking me.